Module 8, Investigation 1, Right Angle Trigonometry. Recall that the measure of an angle corresponds to the fraction of a circle's circumference that the angle subtends. By using the hypotenuse of the triangle below as a radius, construct a circle with its center at the vertex of the angle such that the radius of the circle is 5. Then determine sine of theta without determining the value theta. Hint: consider the process of determining the value theta and consider how the output of the sine function relates to this value. So first, let me just put a circle up here. That's approximately a circle with the center at B. That's what we're going for. Determine sine of theta without determining the value of theta. So, sine of theta tells us the height of this vertical piece in terms of radius lengths. So how many radius lengths are here? Well, the radius is 5. And so we just take our vertical distance and divide by 5 to get the number of radius lengths, 3/5 or 0.6 radii. You could have said the opposite over the hypotenuse. That would have worked too. Using the hypotenuse of the triangle below as a radius, construct a circle with its center at the vertex of the angle such that the radius of the circle is 5.43. Then determine sine of theta without determining the value theta. Okay, the goal is to make a circle with B at the center. Now here we can use the same sort of reasoning. Sine of theta, well, that's this vertical distance measured in radius lengths, which is just 1.92 over 5.43, which is about 0.35 radii. You could again do opposite over hypotenuse. Using the hypotenuse of the triangle below as radius, construct a circle with its center at the vertex of the angle such that the radius of the circle is 4. Find the length of the segment BC and then determine cosine theta without determining the value of theta. Well, we could make a big circle with its center at B, and point A should be on the edge of the circle if this is angle theta is going to be accurate. But here we want cosine of theta, and cosine of theta is actually, let's see, if this is the vertical diameter right here, then cosine of theta is this horizontal distance measured from the vertical diameter in radii, which is the same as this distance down here. But we don't have that distance. So how do we find it? Well, so how do we find this distance here in radii? Well, let's first find it in the standard units. We can use the Pythagorean Theorem. X squared plus 2.4 squared equals 4 squared. Meaning x squared equals 4 squared minus 2.4 squared, which means x equals the square root of 16 minus 2.4 squared. And that's about 3.2. That means that cosine of theta, let's see, if this is 3.2, that's just that length measured in radii, or 3.2 over 4, which is about 0.8 radii. Use the diagram below to determine cosine of theta and sine theta. Well, kind of like we've been doing, we can just take the length of the vertical distance divided by the radius to find the sine of theta, the opposite over hypotenuse. And that's about 0.62 radii. And cosine of theta, take the horizontal distance, 8.3, or the adjacent side, divided by the radius or the hypotenuse. And we get about 0.78 radii there. Using the hypotenuse of the triangle below as a radius, construct a circle with its center at the vertex of the angle theta such that the radius is 11.88. Then determine tangent of theta without determining the value of theta. Okay. That circle isn't horrible, but note that, let's see, this point right here, if this is our origin, if the center is 0, 0, then this point, the x value is 10.62, the y value is 5. I think that's 3.8. Now I can't see it because of my circle. And so the tangent, remember, is just the slope, or sine of theta over cosine of theta. It's kind of interesting. We don't have to use radii for this because the radii would just cancel out. Notice that we could use, like, what these, let's see, how can I phrase this? These points are really r cosine theta, r sine theta. That's what the x and y coordinates are. And if we subtract from 0, divide by subtract from 0, we just get y over x, r sine theta over r cosine theta, which, notice that the r's cancel out, just sine theta over cosine theta. Or, like we talked about in class, opposite over adjacent, but we can just use 5.38 over 10.62. We don't even have to convert those to radii measurements because the result will be the same anyways. So 0.502. And that's the slope of the line. Using the hypotenuse of the triangle below as a radius, construct a circle with its center at the vertex of the angle such that the radius of the circle is 3.96. Okay. How could you use your knowledge of the sine and or cosine functions to determine the measure of theta? Well, we could do this a lot of ways. We could say, this one's a little different because we want to find theta. So we know that sine of theta would be 1.78 over 3.96. That means that theta would be the inverse sine of 1.78 over 3.96, which, if your calculator is in radian mode, you should find that's about 0.47 radians. If you did it with the inverse cosine, you should get the same thing. That would be inverse cosine of 3.54 over 3.96. How could you use your knowledge of the sine and or cosine functions? Okay, we did that. Determine the value of alpha. Well, if theta is 0.47 radians, and all these angles add up to 180 degrees, that means theta plus alpha plus 90 degrees, which is pi over 2. Those all add up to pi, or 180 degrees. Then alpha is pi minus pi over 2 minus 90, or simply pi over 2. Why did I put 90 there? I'm sorry. Theta. I was thinking in terms of degrees, so that's pi over 2, or 90 degrees, minus theta. So pi over 2 minus 0.47 equals about 1.10. So if you need to, you can use degrees. You could find alpha equals 90 degrees minus theta, if you make sure theta is in degrees also. Use the diagram below to determine each value. Sine of alpha. First we better find that hypotenuse. I'll just call it r. 2 squared plus 6 squared equals r squared. So 4 plus 36 equals r squared. That means 40 equals r squared. And so the square root of 40 equals r. Okay, so I'm going to use the basic opposite over hypotenuse strategy. Sine of alpha would equal the opposite, which is 6 centimeters, over the square root of 40, which is the hypotenuse. Opposite over hypotenuse. And we get about 0.95. Cosine of alpha, the adjacent side right next door over the hypotenuse, 2 over square root of 40, which is about 0.31. Tangent of alpha, opposite over adjacent, or 6 over 2, which is 3. Sine of beta, the opposite over the hypotenuse, 2 over the square root of 40. Which is about, well, it's the same as cosine of alpha, so 0.31. Because now the opposites and adjacents are swapping places. Cosine of beta, that would be 2 over the square root of 40. No, sorry. 6 over the square root of 40, because it's the adjacent side, which is, of course, 0.95, because we've already done sine of alpha up there, which was the same thing. And then the last one, tangent of beta. The opposite from beta is 2 divided by the adjacent, which is 6, and so that's 1/3. Or about 0.33. Determine the measures of angles alpha and beta. Well, one thing we could do is the inverse sine of 0.95. We could really do the inverse of any of these. We get 1.25 radians. We could use the inverse cosine of 0.95, and that gives us 0.32 radians. Notice this one is alpha, this one is beta. We could have determined those angles in all sorts of different numbers of ways using the inverse trig functions with these expressions. You might want to try out some of those. Given that sine of theta equals -3/4 and theta is in quadrant 3, determine cosine theta and tangent theta. So here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And sine of theta is -3/4. So basically theta is this way. Here's the terminal side of theta. And we know that this vertical distance here is -3/4 the length of the radius, whatever that is. But if we say that the radius has a length of 1 for reference, then what would this x value be? Well, we can use the Pythagorean theorem. X squared plus 3/4 squared. Notice I didn't use a -3/4 because here I'm just thinking about it in terms of length rather than positive or negative. Lengths can't be negative, really. So 1 minus 3 squared is 9, 4 squared is 16ths. So x squared equals 7/16. And so x is the square root of 7/16. Which is the square root of 7/4. So cosine of theta, since we're looking at the distance to the left, we would say that that's negative, square root of 7/4. And we would say tangent of theta, it's just y over x, -3/4 over negative square root of 7/4. You could put the negative here if you want to for reference, but that turns out to be 3 over square root of 7. Okay, now, you could have done that a much simpler way. Maybe it's simpler, I don't know. This is what I used to do. For some reason I was hesitant to tell you the method at first. Maybe because I don't know if it would always work. But, using the same sort of reasoning, here's our terminal side. We know that theta is this angle here. We're in the third quadrant. We could think in terms of opposite and hypotenuse, like 3/4. It's sort of like you're considering this angle here, and then you have to think, well, that's really a negative, and then you solve for the other side of the triangle, 3 squared plus 4 squared. Actually, 3 squared plus x squared equals 4 squared, so x squared equals 16 minus 9, or 7. X equals square root of 7, and you might want to think about it as negative square root of 7. But then cosine of theta, we can see it's kind of, again, weird, but you could think about it as the adjacent to this angle, which would be negative square root of 7/4. And tangent of theta as the opposite and adjacent, -3 over negative square root of 7, or 3 over square root of 7. That method's kind of weird. Yep, that's the one that the book used, but it doesn't really make sense. It does, but it doesn't at the same time, because this is theta right here, not this little piece. So I recommend thinking about it the first way I solved this problem. You might want to rewind to look at that if you forgot. So given that tangent of theta is negative 2/3, and that, that's alpha, and that alpha is in quadrant 2, determine sine of theta and cosine of theta. So here's alpha. And really this question isn't very good. It really should say the terminal side of alpha is in quadrant 2. Whoever wrote this question must have not been on the same page as everybody else who wrote the rest of the book. Let's see. So you can think about this as the slope, rise over run. Like if we made this one 2 and this one 3, then the slope of this line would be negative 2/3. Then we could find the hypotenuse. 2 squared plus 3 squared equals 4 plus 9, which is 13. And so that equals the hypotenuse squared. So the hypotenuse is square root of 13. That means that sine of theta would be, well, if this is thought of as a radius, then negative 2 over square root of 13. And cosine of theta, oops, I got that backwards. This one is cosine of theta that I just wrote. Sine of theta is 3 over square root of 13. And cosine of theta, alpha, is negative 2 over square root of 13.